Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. So this is the lecture video for week 6. We are still in chapter 2. So this is the final video of chapter 2. So in this video, we will learn about three subtopics. Okay, the first one is about the measure of dispersion for group and ungroup data. Okay, we are going to learn about range, variance and standard deviation. The second one is the coefficient of variation for group and ungroup data. And the final one is the final subtopics in chapter 2 is about the measure of skewness for group and ungroup data. Okay, we look at this subtopic first about the measurement of dispersion. Okay, in the previous week, we have learned about the mean, median and mode. Okay, where mean, median and mode are the example of measures of central tendency of a distribution. Okay, any distribution can be effectively described by measures of central tendency, okay, using mean, median or mode and dispersion. So this time we gonna learn about the dispersion. The dispersion of a distribution provides us with additional information on the reliability of the measures of central tendency. Okay. So the measures of dispersion can be used to compare the dispersion of various samples. So, measures of dispersion can help us to understand the spread or variability of our set data. Okay, measures of dispersion can give us the additional info to judge the reliability of the our measurement of the data. Okay, there are several common measures of dispersion. Okay, the first one is range, interquartile range, variance, standard deviation and coefficient of variation. Okay, we look at the first one first. Okay, the range. The range is the difference between the largest and the smallest value in the data set. So, in order to find your range, okay, you need to subtract largest value with the smallest value of the data. Okay, to find range for ungrouped data, you only just to subtract the largest value with the smallest value. Meanwhile, to find the range for group data, okay, the formula is you need to subtract the upper boundary of highest class minus with the lower boundary of the lowest class. Okay, that's how you find the range for both group and ungrouped data. Okay, the next one is the interquartile range. The interquartile range is the difference between the third and the first quartile in the set data. So our formula is IQR equals Q3 minus Q1. Okay, these measures consider in the spread of the middle of 50% of the data. Okay, because we are talking about Q2. Okay, Q3 minus Q1 is Q2. So it is 50% of the data. Okay, so the bigger the value of IQR, so meaning that the more spread the data are. Okay, next is about the variance. Variance is the average of the squared distance of the observation from the mean. Okay, it is denoted by S2, not S2, S square, okay? S square for sample and sigma square for population. Okay, the next one is the standard deviation. Okay, it is the square root of the variance. Okay, so just now I said that the notation for variance for sample is S square and for population is sigma square. So the standard deviation is the square root of the variance, meaning that the notation for standard deviation for sample is S. Okay, and the notation for standard deviation for population is only sigma. Okay, next is the coefficient of variation. It is a ratio of the standard deviation to the mean. Okay, the ratio between standard deviation and the mean. Okay, we call it as CV. Okay, coefficient of variation or CV. Okay, CV is used to compare the variation of two or more data sets when the values of the data is differ in unit and the same the data set has same unit but having means far apart. Okay, CV is expressed as a percent. Okay, make sure you give your answer for CV in percent form. Okay, so what's the formula for CV? Okay, CV is the ratio between standard deviation and mean. So you need to divide, okay, the standard deviation with the sample mean. Okay, standard deviation divide by mean and then multiply with 100%. Okay, so that's the formula for CV. Okay, how to find the standard deviation for ungrouped data? Okay, for the formula for finding standard deviation for both ungrouped and grouped data is different. Okay, we take a look at the formula for ungrouped data first. Okay, as I said just now, the notation for standard deviation for population is sigma, and the notation for standard deviation for sample is S. Okay, sigma and S. So the population standard deviation can be calculated using this formula, and the sample standard deviation can be calculated using this formula. Okay, you can see here these two formulas are different. Okay, for population, we need to sum up the value of the data distribution minus the population mean. Okay, square. Okay, total up here and divide by n, where n is the total number of the observation, and then square root them. Okay, for sample standard deviation, you need to subtract the value in the data distribution with the sample mean and then square root. Okay, cari total up dia and then divide by n minus 1. Okay, n minus 1 here is n, and then square root lah. Okay, untuk sample standard deviation. Okay, alternatively, these formulas can be simplified into this. Okay, ini samalah lebih kurang dia dalam simplest form. Okay, so this is the formula for population standard deviation and sample standard deviation. Okay, sama. You all boleh guna yang ni ataupun yang ni. Ini adalah simplified version lah. Okay. Okay, for example, okay, we want to find the standard deviation for the data below, where the data is in the form of ungrouped data. Okay, ungrouped data. So using the formula for standard deviation, okay, here, okay, so we need to find our x minus mean, okay, the value of the data minus mean, square root, divide by n minus 1. Or we can use this simplified formula where we need to find what is our x square, okay, and total up all of our x square. Okay, so kita buat macam ni lah. Find the summation of x, so 8 plus 1 plus 6 plus 4 plus 6 plus 2 plus 0 plus 5 equals 32. and then find the summation of x square. Okay, x square means all the data here you need to square. Okay, so 8 square, okay, 8 square, 1 square, 6 square, semua ni kita square kan, and then sum up, okay, all of this. Okay, so you'll get 182. And then insert in the formula for sample standard deviation, where we need to find 1 over n minus 1, and then here is the summation of x square, and here is the summation of x and then square. Okay, this term and this term is different. Okay, where this term you need to square the data first and then total up ataupun sum up dia, and then this term you need to total up the data first and then square it later. So here we get 182. Okay, because dekat sini kita dah cari 182, then minus 32. Okay, this the summation of x, then square, okay, 32 square divide by 8, okay, our n. So here is 1 divided by 8 n minus 1. So just use your calculator and then we'll get this answer. Okay, just now is we learn about the formula for standard deviation for ungrouped data. Okay, so this time is the formula for standard deviation for group data. Okay, of course the formula will be different. Okay, so this is the formula for population standard deviation, and this is the formula for sample standard deviation. Or alternatively, we can use this formula where it is in the simplified form. Okay, sama sebenarnya. You all boleh pilih yang ni boleh, yang ni boleh. Okay, yang mana-mana sama. Okay, let's take a look at this example. Okay, this is the question about the group data. Okay, we have the maximum load here in terms of class, and then we have the frequency, and then we need to find the midpoint. Okay, the midpoint is x, and then fx. Okay, fx means we need to multiply second column and third column, and then here we need to find f multiply with x square. Okay, means that we need to square our third column and then multiply with the second column, okay, to find fx square. Okay, and then just insert in the formula for standard deviation, okay, sample standard deviation. So we get this formula from the previous slide. So here our f, okay, the total of f is 50. Okay, sebab kita total up dekat sini 2 plus 5 plus 12 plus 17 plus 14 equals 50. So here we have 50 minus 1. And then here we need to find the total fx square. So here is our fx square. So we need to total up. Okay, sum up all of the values in this column. So we'll get 591200. Okay, and then minus. Here in the formula, we need to find the summation of fx and then square. So the total fx is in the fourth column, where the value of which is the value of 5430, and then square divide by the total of f, okay, which is 50. So just use your calculator to calculate, and then we will get 5.537. Okay, let's do this exercise. on this data below shows the employees length of service in years in XYZ company. So this is the type of group data. Okay, group data. So you need to calculate the mean and standard deviation. Okay. Okay, for this time I will only show you how to find the standard deviation, because to find mean we have learned it in the previous week. Okay, so yang ni kita buat solution on standard deviation for group data. Okay, so this is, I write the formula first. Okay, this is the formula for standard deviation. 1 minus n minus 1, and then we need to find the summation for fx square minus the summation for x, okay, and then square it, divide by n. Okay, and then square root lah semua sekali. Okay, this is the formula. So f, what is f? F is the frequency. So our frequency is on the second column. Then we need to find x, okay, where x is the midpoint. Okay, the first midpoint is 0 plus 5 divided by 2. Okay, so we got 2.5. And then 5 plus 10 divided by 2, 7.5. Then okay, so I have filled up this column, and then we add another column to find fx square. Okay, fx square. X square, to insert the value here. Okay, so to find fx square, you need to square the value of x in the third column, okay, each of these values, and then multiply with the values in the second column. Okay, so I have filled up our fourth column, and I think we need to add one more row here at the bottom, because we need to find the summation. Okay, summation for fx square and also the summation for x, okay, to be inserted in this formula. So here is the summation of x and summation for fx square. So we need to total up all of the values in this column. Okay, so here we get 62.5, and then for total of fx square, and here the total of fx square is 10112.5. So just insert all of the values we get into this formula. So here our n is the total number of employees, which is 5 plus 7 plus 21 plus 11 plus 6. So our n is 50. So 1 minus 50 minus 1, and then here is 10112.5 minus 62.5 square, okay, divide by n. Okay, so please check your answer with me. I get here my answer is 14.31, okay, for the standard deviation. Okay, please check your answer with me. Compare your answer with me, okay? Okay, next slide is about the variance. Okay, so to find the variance, you need to square the standard deviation. Okay, the standard deviation, as we learned before, you need to square the values you get. And if you want to find the standard deviation, you just need to square root the variance. Okay, because the population variance notation is sigma square. Okay, this is the variance, and the notation for population standard deviation is only sigma. Okay, so this is the standard deviation. So to find the variance, you need to square the standard deviation, and to find the standard deviation, you need to square root the variance. So the formula for variance and standard deviation actually is similar, because it is difference in terms of having square root or not having square root in that formula. So this is the formula for variance, population variance, and population standard deviation. Okay, where you can see here in the formula for standard deviation, we have square root here. Okay, and the formula for variance, we don't have the square root, but the terms here is same. Okay, so we can say that the formula for variance and standard deviation is similar. Okay, similar but not same. Okay, and here is the formula for sample variance and sample standard deviation. Okay, also you can see here the formula is similar, but in standard deviation we have square root here, and for variance we don't have the square root. Okay, what is the usage of variance and standard deviation? Okay, it can be used to determine the spread of data. Okay, the information is useful in comparing two or more data sets to determine which is more variable. Okay, which data is more variable. More reliable. Okay, it is used to determine the consistency of a variable, and it is used to determine the number of data value that fall within a specified interval in the distribution. Okay, standard deviation and variance also quite often used in inferential statistics. Okay, next is the coefficient of variation, or we can call it as CV. Okay, the formula is the standard deviation divided by mean and multiply with 100%. So the answer for CV must be in percentage. Okay, note that the larger the value of the standard deviation means that the more spread out the data is, and the smaller value of CV shows the dispersion is less and more consistent. Okay, if we have the smaller value of CV, meaning that our dispersion is less and the data is more consistent. Okay, look at this example. Okay, we need to determine which distribution is more consistent. Okay, set A, set B or set C. Okay, yang mana yang lebih consistent dia punya data. Okay, so to determine the consistency of the data set, we need to find the value of CV. Okay, CV. So to calculate the CV of data set A, okay, so dia punya standard deviation divide with the mean. Okay, 10 divided by 75, and then multiply with 100. So the CV of data set A is 13.33%. And then CV for data set B, 15 divided by 70, multiply with 100%. So the answer is 21.43%. And lastly, for the CV of data set C, Okay, 7 divided by 60 multiply with 100%. So the answer is 11.67%. So from the calculation here, it can be concluded that the set C, okay, set C is less dispersed, okay, and more consistent, since it has the least percentage of CV. Okay, the percentage is the smaller compared to CV of data set A and B. Okay, so we can say that set C is more consistent. Okay, let's take a look at this exercise. The employees of ABC company has the mean and standard deviation of 12.5 years and 2.98 years respectively on working areas. So this is our mean. Okay, mean. And this is the standard deviation. Okay, determine which company has more consistent data. Okay, this is the data for company ABC, okay, which is the mean. Here is the mean and here is the standard deviation. We want to compare with another company called company XYZ. Okay, given the mean of this company is 13.1 and the standard deviation is 5.59. Okay. Okay, so to find out which company has more consistent data, so we need to calculate the CV for both company. Okay, the first one is CV for ABC company. Okay, the standard deviation is 12.5 divided by the mean. The standard deviation is 2.98. 2.98 divided by the standard deviation, divide by the mean, which is 12.5, and then multiply with 100%. Okay, 2.98 divided by 12.5. Okay, so the answer is 23.84%. Meanwhile, the CV for XYZ company is standard deviation 5.59 divided by the mean 13.1. Okay, multiply with 100%. So the answer is 42.67%. Okay, so the results show that the company ABC has more consistent data compared to company XYZ. Consistent data. Okay. So in conclusion, we can say that the more spread out or the more dispersed of the data are, the larger will be the range. Okay, the interquartile range and the variance and the standard deviation. Okay, range dia kita akan dapat jawapan lebih besar, as well as interquartile range, the variance and the standard deviation. Second one, the more concentrated or the more homogeneous the data are, okay, so we will have the smaller value of range, IQR, the variance and the standard deviation. If our observations are all same, the data are all same, meaning that there is no variation in the data, so our value of range as well as IQR, variance, and the standard deviation will be all 0. And lastly, noted that the value of range, interquartile, standard deviation, and variance can never be negative. Okay, the last subtopic, we are going to take a look at the measure of skewness. Other than the measures of central location and dispersion, okay, another important measure of distribution is the skewness of the distribution. Okay, a distribution can be symmetric, skewed to the right, or skewed to the left. If in a set of data, if the mode is greater than the mean, okay, the mode is greater than the mean, like this graph, this means that there are more values bigger than the mean. Okay, mean is here, and a lot of values are bigger than the mean. Okay, and the smaller value are more widely spread, so the distribution is skewed to the left. However, if the mean is greater than the mode, okay, like this figure, okay, the mean is greater than the mode is here and mean is here, so mean is greater than the mode, the distribution is skewed to the right, or we can call it as positively skewed. Okay, if the mean, median, and mode are equal, okay, mean is here as well as mode and median, all is here, so the distribution is equally spread on both sides. Okay, left side and right side is equally spread. Okay, then it is said that the distribution is symmetric. Okay, so this distribution usually have bell shape. So these are three common shape of a distribution. Okay, actually, we can measure the skewness of a distribution by these four method. Okay, the first one is by histogram. Okay, by looking at the shape of the histogram. The second one is by the frequency polygon. Okay, also by looking at the shape of the frequency polygon. The third one is by determine the median, mean, median, and mode. Okay, we look at the position and the shape. Okay, so only then we can know the type of the skewness. Okay, and the fourth method is by the Pearson coefficient of skewness formula. Okay, ini adalah formula lah, we need to calculate. Okay, by histogram, from the histogram, the shape of distribution here in this figure, we can see that the shape of distribution is skewed to the left. Okay, or we can say that it is negatively skewed. Okay, sebab dia lebih tinggi kat sebelah kanan ni. Okay. Okay, that's how we determine the skewness from the histogram. And then the second one, to determine the skewness from the frequency polygon. Okay, we can get our frequency polygon from the histogram here. Okay, from this histogram, and then we construct our frequency polygon. Okay, so from this frequency polygon, you can see that the distribution is equally spread on both sides. So we can say that the skewness is symmetric. Okay, symmetrical. Okay, the third method to determine the skewness is by looking at the mean, median, and mode. Okay, so mean, median, and mode can be used to determine the shape of the distribution. Okay, if the mean is less than median, and then the median is less than mode, okay, the distribution is negatively skewed. If the mean, the value of mean equals median and equals the value of mode, so the distribution is normal, okay, normal distribution, so it will be symmetric. Third one, when the mean, okay, the value of mean is larger than median and the value of median is also larger than the mode, then it is skewed to the right, or known as the positively skewed. Okay, so it means that we need to calculate the value of mean, median, mode first, and then look at the values whether the mean, median and mode are less than or more than each other, and then and only after that we can decide the shape of the distribution. Okay. Okay, let's take a look at this exercise. The following table shows the summary statistics of test score of a group of students after they attend one motivation program. Okay, so this the median, mode and mean are given here. So by using the above three summary statistics, we need to sketch and comment on the shape of the test score distribution. So we can see here the median, the value of median is larger than the mode, and then the mean is larger than the median and mode. So we can say that the mean here, mean is the largest one, and then median, and the mode is the least. Okay, so we can sketch the distribution here. Our mean, okay, so our mean is here, mean, where it is 81. Okay, median is 70, and mean, mean is 83.5, and our mode is 70, median is 81, mode is here lah, mode, okay, mode is the our least value. So if the mean is greater than the mode, so the distribution is skewed to the right based on the previous slide. Okay, so we need to sketch the distribution graph where it is skewed to the right. Okay, so dia macam ni lah. Okay, lebih kurang. So it is skewed to the right. Okay, so that's the solution for this question. Okay, as I mentioned before, this is another method to determine the skewness, okay, the skewness of the data by using Pearson's coefficient of skewness, or we can call it as PCS. Okay, PCS is used to measure the degree of skewness of the data set. So there are two formulas to choose, whether you want to choose this formula called Pearson's first coefficient, or this formula called Pearson's second coefficient. Okay, depending on what value we know. Okay, the first formula, the Pearson first coefficient, we need to subtract mean and mode and then divide by the standard deviation. And for Pearson's second coefficient, the formula is 3 times with the mean minus median. Okay, and then divide by the standard deviation. So if we know what is our value of mean and mode and standard deviation, we can choose to use Pearson's first coefficient. Or if we know our value of mean and median, okay, mode kita tak tahu, mean and median and standard deviation, so we can choose to use Pearson's second coefficient. Okay, note that if our value of PCS is equals 0, okay, meaning that the distribution is symmetry, or it has the normal distribution. If our PCS is less than 0 or negative number, okay, our PCS is negative number, then the distribution is skewed to the left, okay, or we can call it as negatively skewed. And if our PCS is more than 0, meaning that we have the positive answer, so the distribution is skewed to the right or positively skewed. So the greater the value of PCS, okay, the greater value of the PCS, the more the distribution is skewed. Okay, let's take a look at example and solution here. Okay, determine the skewness of the distribution by using PCS. Okay, you are given the value of mean here, mean, median, and mode, and also the standard deviation. So since all the central tendency measurements we know, mean, median, mode, standard deviation semua are given, so we will show both method, okay, of PCS using the first coefficient and the second coefficient. Okay, dua-dua formula ni kita boleh gunalah sebab kita tahu mean, median, mode, standard deviation semua kita tahu. So this is when we use the Pearson's first coefficient. Okay, mean minus with the mode and then divide by the standard deviation. So the answer is negative 0.367. Meanwhile, if we use the second formula, which is the Pearson's second coefficient, so the formula is 3 multiply with mean minus median. So mean here is minus median, multiply with 3 and then divide by the standard deviation. So the formula, the answer is negative 0.358. So both answers are negative, which is interpreted as the given data set is skewed to the left or negatively skewed. Okay, let's do some exercise. On this questions is about the ungroup data. Okay, the first question is about you are asked to find the value of median and mean. Okay, the second question is you need to interpret the mean value obtained in the first question, and the third question is you need to calculate the coefficient of skewness, okay, given that the standard deviation here, and comment on the shape of the distribution. So we need to calculate the mean first. Okay, so this time we need to use the formula for finding mean of ungrouped data. Okay, which is the formula is mean equals total of x divided by n. Okay. Okay, the total of x is 11896 divided by our n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, divide by 12. So the answer for mean is 991.33. Okay, and then to find the median, we need to find the position of the median first. Of median. 12 plus 1 divided by 2, okay, which is equals 6.5. So the position of median is 6.5. And don't forget to rearrange this data, okay, according to the least to the most, okay, because we need to determine our median. Okay, the position of median is 6.5. So where is our 6.5 position? So kita rearrange dulu. So this is the data that I have arranged. So our position of median is 6.5, meaning that here is the first position, first, second, third, fourth, fifth, sixth. Okay, 1, 2, 3, 4, 5, 6. Okay, 6.5 is between these two numbers. So we need to find the average lah. Okay, so median, the median is 975 plus 1046 divided by 2. So the answer is 1010.5. So that's our median. And then for the second question, we need to interpret the mean value. Okay, mean value obtained in 1. So on average, there are 991.33 tourists visiting a museum from July 2001 to June 2002. Okay. For the third question, calculate the coefficient of skewness given the standard deviation is 204.9. Okay, so to calculate the coefficient of skewness, we need to use Pearson coefficient of skewness, which is PCS. Okay, so we have the value of mean, median, as well as standard deviation. So we can use Pearson second coefficient formula. Okay, so the skewness, the formula is 3 multiply with mean minus median divided by the standard deviation. Okay, our mean is 991.33 minus median divide by, given the standard deviation is 204.9. Okay, so the answer is negative 0.28. Okay, 07. So our skewness is negative. Okay, so the distribution is skewed to the left. The distribution is skewed to the left, or it is negatively skewed. Okay, that's the solution for this exercise. So this is the end of chapter 2. So if you have any question, so you can PM me in Telegram. Okay, okay, don't worry, I will give okay, sorry, don't forget that our assignment, individual assignment, is on week 7. Okay, next week. Okay, so be prepared. The answer, the question is on the topic chapter 1 and chapter 2. Okay, the weightage is 10%. Okay, so I will end this video, and if you have any question, you can ask me anytime on the Telegram. Okay, Assalamualaikum warahmatullahi wabarakatuh.